Throughout the Vietnam conflict, the United States Navy aerial reconnaissance aircraft have been facing a major test of their capability. Their performance has been outstanding. Flying mission after mission through what is recognized as the heaviest concentration of anti-aircraft defenses the world has ever known, Navy pilots have consistently brought back vital information on enemy activities, movements, and results of strike missions. Because of this high-risk environment, substantial losses of aircraft and air crews were sustained. To reduce this costly attrition of lives and resources, a requirement was established for an unmanned reconnaissance vehicle, organic to the fleet, directly responsive to the task force commander, to supplement the manned reconnaissance force. In response to this requirement, on November 4, 1968, the Navy awarded a contract to the Ryan Aeronautical Company for design and fabrication of the Model 147 SK Spray Special Purpose Reconnaissance Aircraft. 10 of these Special Purpose Reconnaissance aircraft are now being built for an operational evaluation program to be conducted by the Navy in the fall of 1969. The 147 SK Spray results from technology and experience amassed by the Ryan Aeronautical Company in unmanned aircraft during the past 20 years. It is an evolution of the BQM-34A Firebee target drone that has been operational in the Navy since 1959. Ryan Firebee drones, currently operated by the Navy, can be air-launched, ground-launched from a land-based zero-link launcher, or surface-launched from a seagoing platform. Mission complete, the drone is recovered by a two-stage parachute system and may be retrieved from the water by helicopter or boat, from land by helicopter or truck, or in midair by a specially modified helicopter. Following refurbishment and pre-flight checks, the drone is ready for its next mission. These same operation and maintenance procedures have been applied to the 147 SK Spray. This new Navy reconnaissance vehicle is 28.5 feet long and has a wingspan of 14 feet. It is powered by a Continental J69T41A turbojet engine developing 1,920 pounds of thrust at static sea level. An aerial camera is housed in an environmentally controlled nose section. The Fairchild F415Y panoramic camera has a 3-inch f2.8 lens with 1,800 feet of 70-millimeter film. It provides horizon-to-horizon coverage for a longitudinal distance of 155 nautical miles. This camera has automatic exposure control and image motion compensation, which provides 60-degree overlap. At a nominal operating altitude of 1,500 feet, ground resolution of less than 6 inches at nadir is achieved. To maintain accurate target coverage, a navigation system composed of an MA1 compass, a Doppler navigator, a digital programmer, and an automatic flight control box is incorporated in the Spray. This system has a 3% of distance traveled navigation accuracy when flown hands-off during the pre-programmed portion of the flight. Prior to entering the programmed flight mode, the vehicle is flown under secure remote manual control using the DRW-29 radio receiver, APX-71 L-band IFF transponder, and Dorset TM-431 telemetry transmitter. The vehicle is surfaced launched using the Mark 23 Mod O ASRock booster, delivering 11,000 pounds of thrust for 4.4 seconds. Ground launch using this booster on the VQM-34A was successfully demonstrated in 1965. Successful recovery of the spray is a vital aspect of the system and is accomplished using the mid-air retrieval system, MARS. This technique assures timely information retrieval, minimizes equipment damage, and radically reduces the time required for maintenance turnaround cycle. Under the guidelines of the Chief of Naval Operations and within the parameters of the Operational Evaluation Program, the 147SK system and its 21-man detachment will deploy to the Western Pacific Theater on the carrier USS Bennington, CVS-20, following the flight demonstration at the Naval Missile Center, Point Mugu, California. For operations in the combat environment, the 147SK will be surface launched from a mobile launcher located on the after starboard elevator. Launch will be made from the flight deck level. At launch, a remote control officer in the Combat Information Center will stabilize the vehicle on a predetermined heading, altitude, and airspeed. He will then pass control to a remote operator in an E-1B aircraft, which has been modified for drone track and control. By painting the coastline or other identification points and tracking the 147SK spray, the airborne remote control officer guides the vehicle to a pre-selected geographical reference coast-in point. As the vehicle crosses this point, the programmed covert segment of the flight begins and the radio receiver, telemetry, and tracking equipment are secured. During the hot phase of the mission, the camera will be automatically controlled to operate and photograph the pre-selected targets. Once the target run is completed, the vehicle will ascend to a higher altitude for egress. After leaving hostile territory, radio, telemetry, and tracking systems are activated by the programmer, and positive control will be reacquired by either the airborne or shipboard controller. At the intended recovery point, the controller initiates recovery, and the helicopter accomplishes mid-air retrieval. The film is then delivered to the task force commander at the Integrated Operational Intelligence Center for processing and interpretation. The 147SK is then recycled for further mission assignments. The primary objective of the operational evaluation is to confirm that the total 147SK system provides useful and timely information to the task force commander, which effectively benefits the manned striking forces and realistically complements the manned reconnaissance forces. The operational evaluation will determine the 147SK compatibility with shipboard environment, verify operational concepts, demonstrate personnel and maintenance procedures, and assure interface with manned aircraft operations. Once these initial minimum objectives have been attained and 147SK performance demonstrated, added capability and growth features can be added to enhance versatility with a resultant increase in effectiveness. This can be done by taking advantage of proven developments from other reconnaissance programs and technological advancements in sensor capability. A forward oblique camera can be added to complement the vertical camera installation. A data link system can also be added for transmitting information on a real-time basis to a receiving station, either by direct downlink or via airborne relay. The data link can be interfaced with a television system whose imagery can be monitored in real time or stored on videotape for later viewing. By augmenting the F-415Y camera with a TV data link, navigation updating can be achieved or en route selective retargeting accomplished. Strobe systems can be used for night operations, or laser and infrared sensor systems can be palletized in interchangeable nose modules and also used for covert night reconnaissance. In a number of these systems options, the imagery can be recorded on board the spray for later retrieval or transmitted back via data link. Like all Ryan unmanned reconnaissance systems, the 147 SK system exists for one purpose only, to produce timely and effective intelligence. Ryan Aeronautical Company's demonstrated success in unmanned aerial reconnaissance systems will make the 147 SK Special Purpose Reconnaissance Aircraft System fully responsive to the Navy's requirement for worldwide surveillance.